I still haven't done this.
Oh, stop it. Oh, the
Is it?
segment four?
Yes.
Okay. So we're going to do some review today to help you with your next quiz, which is not next week, but the week after that. Any guess on what the quiz is on? There you go. Right. So we're going to do some high-level state machine practice. So here is your first high-level state machine description. Work on this together for this first one. And then your code for today is, don't do this one. It's still 317. It's not activated right now. Lecture 26. All right. So it's 317. Go ahead and answer A right away. And then when your group is done, change your answer from A to B. Okay?
317.
317. Answer A immediately, but then when you're done, change it from A to B. You guys can work on this together. I'll rephrase and say you should work on this together.
Absolutely.
Thanks.
This is output generating, is that an I or a one? I plus offset, I minus offset, or was that supposed to be?
This input, I.
Input?
So your input is dual purpose. It's used to set what the offset is, as well as it's your message to encode or decode.
The inputs are described. So,
So you're gonna, the last day as the set on seven. I was. Yeah. Easy.
So,
Let's do one. That's really. But. I.
Sometimes so B is one to say, so make this our last day, that means. You know, skip every single thing we have. So they also said he is watch it, and choose residue. Then we could put those because we didn't have to, then you have five plus officers. And it puts. If we choose zero, we can another, and then I'll use your other to go into it, right? And then if B is as a watch, like, okay, B is the first one, that's how I would do it, but here's the, here's the. You let it explain this. And that's what. These are also.
Won't leave.
For the service.
No, it was actually.
The inputs was. Inputs for our inputs, which is. Okay, so our initial state So our state. System. It should stay there. We get one. See one and then we go to it was the story. This is state zero, state one. From state one. Okay, I is the, that I can. I asked questions, so we may not have enough time. It's not so easy. There is. So that's state zero. Yeah. Or no, state zero outside. Each line, each name. Then when B is one, you're gonna use that in both systems. Equals. It does not, but
Mm-hmm.
do you know what CS 464 is?
464. No. Do you know the title?
B is zero numerical analysis and computing. Do you know what you're doing that for? So when you state one.
I have a guess of it's going to be about Turing machines, but that's a guess. Just from the time.
But if you needed CS 111 and Calc 2 to get into that class. Yeah, we don't want to touch state. You do like, the state one is just to set that kind of stuff, like the offset. State two.
Maybe.
You're enabled.
If those are the prerequisites, that would make sense.
Because Calc 2 is basically just integration, Taylor. It's 1, 2. That's Calc 2.
Yeah.
So you have to see it's zero. Like how we did on the.
Are you thinking of taking it?
So you have a variable JRIC. I talked to us, the professor said like, he wanted to get a math minor, I'll give a big class of, I don't know, for EV. Because it is a math course and a skills course at the same time.
But why do you want a math minor?
One extra class. Because on top, because I don't know, because I'm already taking a physics minor and an EE degree. If I add a math minor, just one extra class, and it won't take me longer to graduate.
It's up to you, man. I don't know how much this math minor is going to help you, though. Be honest with you.
It's just kind of this guy here.
Okay.
It's just my help.
Okay, so half of us are done. A little more than half of us are done. We'll do maybe 2 more minutes. And we can go over it. Okay, so most of us are done. So let's go over this together. All right, let's start with what are my inputs? Hmm. B, E, and then I is how many bits? Do we have any other input? No. Output? How many bits?
$32.
Yep. What storage do we need?
Need 2 registers, right?
What are we gonna call them?
Offset plus, offset minus.
Not quite. One of them is offset. 32 bits, right? The other one is our output. So our output JReg would just be either going to be the result of the plus or the minus. So this is our definition of inputs outputs of our finite state machine. Next thing to do is what? And what should my first state be? What do I want to call it? Call it anything, but what do I usually call it? Okay. So what should we initialize in this state?
So it should be 32 items.
Not quite. Nope. B is input. What do I normally do to my registers? Yeah, set them to 0. So that means offset is 0, JReg is 0. Okay. And now I'm going to have this new state. I'm going to call this load. When should I transition to load? I'll just put B, right? That means B is, what do I do in load? Offset is I, right? Now let's add one more state. Let's call this encrypt. When should I transition to encrypt? So B naught E. I go to encrypt. What do I do in encrypt? Goes into JReg is I plus set. And then my last state when do I transition here? What do I do in here? All right, am I done? I'm not done, right? What do I need to add?
You said.
That's this arrow right here.
To connect load to encrypt your report,
Mm-hmm.
add a specific.
So when would I stay in load? When would I go from load to encrypt? When would I go from load to decrypt? Am I done now? What am I missing?
That, when B is when you're in an encrypt and decrypt.
B. And then I'm going to change colors so I can just overlap things. B. When do I stay in decrypt or encrypt? And use 1. This one is use 0. Right?
Then can't go to encrypt to decrypt if it was B and 0.
Now am I done? I'm done now. Yeah.
Can you explain the I input in this, like where I plays a part of it?
I'll show you in the data path because we're gonna need to draw the data path now. So what do we need in our data path? Let's draw this box. We have I, right? As input. Do our other inputs need to be input into data path? Where would they be input? Where would they be consumed? B and E, right? Yeah, the controller would be using those. So we don't need to worry about them in the data path. So our data path needs to do a couple things. What are those things that it needs to be able to do?
I plus. Offset.
What else? There's one more thing it needs to do. Set offset to I, right? So let's do that first. So we have this register. It's called offset. It gets an input from I, right? And we have this offset register. So now we have these outputs. Let's call it O clear, O load. Right? And then you mentioned that we need to be able to add and subtract. So let's do that with an ALU, right? One of this operands for ALU is offset. The other operand is I. Where does the result go? That's where the result goes. And now let's add our controls. We have to tell the ALU what to do, right? Is it add or is it subtract? We have to be able to reset JReg. We have to be able to clear. So J clear, J load. And then this is our output. JReg. Right? So is it more clear for you what I is for now? I is both to save what the value is being used to encrypt when it is in the load states. And then when it's in the decrypt or encrypt states, it's the other operand that we are trying to either decrypt or encrypt. So it's this dual purpose input. Is it good for you? That's JReg. Output of JReg based on the state would be either the encrypted value or decrypted value. The user would know because that's what they asked the machine to do based on the control inputs, right? And then next step would be make the control, right? And the controller would set all of these control signals. Like when we're in the init state, what does OClear need to be? What does it need to be? When we're in init, what does this signal need to be? What does this need to be? And then if we're in load, what does this need to be? What does this need to be? What does this need to be? We don't care, right? We're not using it. What does this need to be? Yeah, it should be 0. What does this need to be? Should be 0. We're not using it. Loading. Yeah, that's we're loading into offset. We're not loading into JReg. And then for encrypt, what does this need to be? In encrypt, do I clear offset register? No, so what does this need to be? Am I loading into offset register? And encrypt, So what does this need to be? Yeah, so let's call it, if it's 1, it's adding, right? So let's say that's 1. What does jclear need to be? Yeah, 0. Jload 1, right? And then decrypt. Zero. And then let's say that 0 is subtract, right? So we would tell it to subtract. What does jclear need to be? And jload, right? So then we have all of our signals that need to be set for each of these states. Yep. Wait. The description for which? Uh-huh. It's okay. Not really. Because we don't care what E is when we're in an it, right? So it's not exactly the same thing. But B and E are what determines which state we go to next. And it's the state that determines what should these control signals be. Okay, so we don't have a lot of time, but we do have another example. So I'll let you guys work on this one together until the end. And I will write down the answer while you guys work on it. And I can provide the answer at the end, but I don't think we have enough time to fully go through it. And for this one, I'm just going to draw the high-level state machine.
So CT minus WT. Yeah, you just need it. So. So CT. So positive.